Welcome back. Thanks for sticking with us through that quick break. Up next, we have Josh Keaton, who is joining us with his presentation about innovation in electronic monitoring. Everyone tuning in on Hopin will notice that you have that chance to submit questions during the forums in the forum stage chat and or Q&A tab, whichever works best for you. And I, the moderator, will go ahead and relay those questions to Josh. And so Josh Keaton is the monitoring branch chief for NOAA Fisheries Alaska region. He leads a team that implements and manages the systems used to collect data necessary to manage the federal fisheries off Alaska. Prior to this position, he worked for almost 20 years as an in-season manager for the groundfish fisheries in federal waters off Alaska. Specializing in pollock and prohibited species catch management, over his career, he has developed new management methods and fostered collaborative partnerships to ensure that North Pacific fisheries are sustainably managed. Welcome, Josh.
Thanks. Glad to be here. Get set up here. All right. Welcome. Good morning, all. As was mentioned, I'm here to present about the innovation in electronic monitoring, specifically to talk about the development of EM for pelagic trawl vessels in the North Pacific. So as mentioned in my bio, prior to my position in this monitoring branch lead, I specialized in managing the pollock fisheries. And the last time I presented at a conference in Kodiak. I was sharing about collaborative solutions. We were working with Alaska Groundfish Data Bank in the management of the pollock fishery through the implementation of voluntary catch shares. This presentation is going to be slightly different than that. We're going to talk about development of technology and how we use that to monitor our fisheries. In a normal presentation, you end by talking about the project partners, but I wanted to shift it up a little bit and start with talking about the project partners because honestly, we had a lot of growth in this last year, and it wouldn't be without the open and willing conversation of all these participants to get us to where we are and to have some of the success that we have. The first three I want to recognize is Ruth Christensen with United Catcher Boats, Julie Bonney with Alaska Groundfish Data Bank, and Charlotte Levy with Aleutians East Borough. These three individuals were the ones that put together the EFP application, is communicating with the vessels and organizing everything. So without them being on the ground, we wouldn't have gotten this off to the start that we have. Also, I want to recognize the captain and crew of the 70 pollock catcher vessels that have participated in this project, the multiple tender vessel captains, and the plant managers and the processor crew that assist the observers. Finally, and then we have the EM service providers. These are the people that provide the EM systems. It's Archipelago that provides systems in the Central Gulf and the Bering Sea and saltwater in the Western Gulf. And then we have Courtney with Pacific States Fishery Management Commission, who does all the EM review. We have observers in the plant, and there's 3 EM observer providers. That's Saltwater, AIS, and Alaskan observers. And I also want to put out a special shout out to the Fishery Monitoring and Analysis Division. This is also known as the North Pacific Observer Program. They're out of the Alaska Fisheries Science Center, and they have put a lot of effort into this. Funding was provided by a NIFWIF grant under the Fisheries Innovation Fund, the North Pacific Fisheries Research Foundation. Most of the Bering Sea pollock vessel participants have paid fees into the program to support it. And then Gulf of Alaska vessels also donated the proceeds of their overages to help support the development of this program. Once again, we wouldn't be where we were without the strong collaborative partnership that we had with all of those. So I want to start the presentation by giving you just a brief overview of EM in Alaska. So the primary goal of using EM is to use the appropriate electronic technologies to collect timely, cost-efficient data needed to manage U.S. federal waters fisheries. So electronic technologies is a broad term. It includes things that we, like VMS, on the vessels. So we use some terms a little bit differently than maybe used in other regions or other parts of the world. So when we talk about electronic reporting in the Alaska region, it usually refers to our e-landings, right? If you're a catcher vessel and you make a landing to a processor plant and you get your fish ticket back, that's all done electronically through the e-landing system. It also incorporates the electronic logbooks. When we talk about electronic monitoring in the Alaska region, it usually refers to the video camera systems used to verify or collect the fisheries data. And currently, we have two kind of types of EM systems. We have the EM system that's the primary objective is for catch estimation, and that's the program that we have for the small fixed gear vessels, where the primary objective, as I said, is catch estimation. And then we have the other side, which is where we're going to focus more on this talk, which is the primary objective is to monitor compliance on board the vessel. So we have a few instances already of EM implemented. You have on the larger catcher processors that fish in the Bering Sea and some in the Gulf. We have EM on board to ensure that it's unsorted catch before the observer has the ability to collect their stuff. We have compliance monitoring for our motion compensated flow scales. And then we have, EM systems to assist in the Chinook salmon bycatch management to ensure all salmon are sorted and stored according to regulations. So with any EM system, there's a few common elements. The first element is, well, the EM system itself. So electronic monitoring uses passive electronic systems, usually cameras linked with sensors to monitor a variety of fishing activities. And so the typical things that are involved in an EM system is you have your EM control system, your computer, right? It stores all the information, it encrypts it, and it's designed to be tamper-proof as well. That's linked to a GPS receiver, which acts like a VMS system, which gives us the spatial location information and pinpoints the fishing times and locations. And then you have sensors like the hydraulic and drum rotation sensors, which can be linked or can indicate when fishing activity occurs. And then finally, you have video cameras. Another common element of
Josh,
an EM system.
really quickly, I'm sorry, I want to interrupt
Sure.
you. We're not seeing the slides as you're showing them. And so I know that we tested this ahead, but everyone, please bear with us. This is new technology for us. So we did test it ahead. It was working. But if you'll give us just a moment to sort it out, we'll get it set for you. And Josh, if you'd like me to use the backup slides, you just let me know and I'm happy to pull those up.
Would you like me to try to start the presentation again?
Yeah, that'd be great.
We can do it via screen, I think. Let's see if that works. Can you see the slides now?
We see the slides, also the notes.
Okay, hold on just a second. How about now?
Okay, we're all set now, thanks.
All right, well, I apologize for little technical difficulties, but that's what we live with in our current times. I was sharing prior to the presentation, prior to like last May, I didn't have a video camera in my house, and now my living room is set up like an EM system so the kids can do their schooling. So, all right, get to the slide. All right, so picking up where I left off, I guess I'll show this because it's a nice graphic of what the EM system is to help you visualize. As I mentioned, the computer system, the GPS, the video cameras, and the sensors are all linked together. So another common element of a EM system is the VMP, and the VMP stands for the Vessel Monitoring Plan. And this is sort of like the user manual for the EM system. This is a document that's used by both NOAA Fisheries and the EM vendors to communicate what the vessel responsibilities are in support of the EM. On the screen here, you can see an example of the VMP prior to you could see that on the first page, right, it identifies who to contact if you have problems. And then inside it says like vessel operator responsibilities, where it outlines how to run a function test to make sure that the system is working, how to confirm that you have hard drive space to collect the information, and everything that the vessel operator should do to keep that EM system operating. It also shows on the right here diagrams of where the cameras are placed on the system, right? In case another EM technician that didn't install your system needs to work on it. It provides all the information about what that system is, and the camera views are used by the agency to verify that we have good views to measure what we need to measure with that EM system. And finally, a diagram just to bring it all together. So we collect all this information, right? It gets sent by a hard drive, and so there's an EM review side of the EM system. And so an EM viewer needs to be able to take that raw image data or video data and translate it into data that can be used for catch accounting. So here's a screenshot of one of the what programs that are used by the EM reviewers. And what I want to show you is it shows all those sensors here, so you can see when the fishing activity occurs. Now, this particular example is for one of our fixed gear EM boats, but the same concept holds true for the Trawl EM program. It lets you know when fishing starts, so it helps the EM reviewer identify when they need to look at this or look at the data or pay more attention to it. I want to talk a little bit about the brief history of EM development off of Alaska, just to give a snapshot of where we are. We started in this program, or started developing EM, particularly for this in about 2013. The council created an EM work group to start exploring EM as a catch accounting tool on the fixed gear vessels. It was put into the ET implementation plan, and then throughout 2016 to 2018, there was a lot of work towards implementing an EM system into regulations for small fixed gear vessels, right? In 2018, the council chose to shift the focus of the EM work group, renamed it to the EM Trawl Committee, to start developing the use for pelagic trawl catcher vessel fisheries. In January of 2020, NIMS approved an exempted fishing permit to evaluate this program. Council re-reviewed the ET implementation plan in February 2021, and we currently have fishing occurring under the EFP. All the project partners are meeting every 2 weeks. We're discussing any issues and making modifications as necessary as we move towards a regulated program potentially. So any EM has a development process, and we put together this graphic several years ago just to talk about all the various factors you need to think about when you're in the stages of EM development. And so we're through the proof of concept phase, we're through the pilot program, we're mostly through operational testing, and right now we're kind of right between operational testing and pre-implementation, if not leaning a little bit towards pre-implementation. So that's where we're at in the process, and we hope to continue going down this process here, and that's what we're going to talk about here in a little bit. So why did the council choose pelagic fishery as the next step? Well, if you don't know already, directed fishing for pollock is a very high volume fishery. In fact, it is the largest fishery by volume in the United States, and it's one of the largest, most sustainably managed fisheries in the world. It is that way because when a vessel goes out to fish pollock, they catch pollock. 98.7% of total catch is pollock. That is all data collected by pollock vessels over the last 5 years, and then the pollock divided by the total catch. 98.7% of all species harvested was pollock. The other reason is the West Coast region was in the process of implementing an EM system that was very similar to what we were looking at for pelagic pollock. It was a similar fishery, the Pacific whiting fishery. And so many of the pollock vessels that were interested in starting in the Alaska region for the EM system already had EM systems installed, right? Another reason is bang for your buck, right? Pollock fishery is one of the largest fisheries in the world. It accounts for over 90% of all groundfish catch delivered to a shoreside processor in the Bering Sea. So high volume and low bycatch, right? Kind of a logical next step in EM. So the other thing is we had the opportunity, we know from having observers on these vessels what the fishing is like, right? The high volume, the lack of bycatch, sorting at sea is difficult. It's not very efficient. So it really allows for the maximized retention type fishery to enable collection of data shoreside. The Bering Sea pollock fishery already had 100% observer coverage, and we know what the observer duties during the trip are and where we can shift those at. The plants in Dutch Harbor and Akutan already had what we call catch monitoring control plans to assist the observers in the collection of that information. And so we decided to give this a shot. So now we're going to shift focus to talk about the Trawl EM program in general. So in year one, we had about 47 catcher vessels volunteer and participate in the program. If anybody has read the news in the last year, right, something happened that's affected all of us in our daily lives. And so we had a request to increase it in year two. Plus, we had a lot of success in year one. So we increased the number of vessels to about 70. As I mentioned before, observers are shifted from the vessel into the processing plants to collect their catch and biological data, and we use video to ensure that there's full retention. Now, when I put this presentation together, I thought I would have. I had a plan. I wanted to show a video clips of a pollock haul just to help visualize. Over my 20 years of working with hundreds, if not thousands, of fishermen and understanding fishery regulations, I've always found that visualizing and understanding what goes on the boats really helps you communicate. So in the next series of slides, I'm just going to go through a typical pollock haul. And all of these views were collected through the EM system. So you can see exactly what an EM reviewer sees. And I'll talk you through the pollock haulback. So this is about 5 minutes after the start of the haulback, right? The bag or cod end is floating on behind the vessel. The EM reviewer is going to be looking for any fish streaming out of the net from like a torn net or a blown out panel or anything else, and trying to record that information. You can also see the views from the deck. There's not a lot of fish coming on, a lot of jellyfish there in the trawl alley, and a few pollock that were stuck in the early parts of the net. You move on to about 10 minutes after this there, and the horizon view largely becomes clear. So two of the cameras, they're still in view, but the EM reviewer is going to start focusing on the two larger pictures here on the slide, which are the views of the deck. And there could be more than two cameras on the deck depending on the vessel configuration. So they're going to be watching, and they're going to be watching the activity here to ensure that this pollock is being retained. Now you can see in the bottom picture just a little bit that the fish is starting to spill out of the net. And what you can't see, and you'll see it a little bit later on the slides as the net moves, but the holds are open underneath this net. So that fish is spilling directly from the net right into the RSW tanks. About 15 minutes in, you can see that we're probably about a third of the pollock has already come out of the net, and it's starting to drain out, or I guess drain out of the net. But you can notice there's no crew members touching the fish, moving the fish, sorting the fish, anything like that. And that's what we'd like to see on these EM views, because we're looking to make sure that no fish goes over the side. About 20 minutes in, net's almost empty. You can see the pollock in the trawl alley there. And then about 25 minutes in, we're almost done, right? At this point, this is when the crew starts to sort of handle the catch. So you start to pay attention a little bit more. And what they do is they go out with shovels and they shovel all that catch down into the hold. And those are the last two pollock left to be stored from that haul. So I hope that gives a good visualization that what we're doing is we can verify that all catch harvested in that haul has been stored and will be available unsorted to the observer on the shore side. So let's talk about the data needs. So in these slides, on the left side and in orange, we talk about what the current regulations are with observers on pollock catcher vessels. And on the right side in green, we're sharing what the changes are, what's going on under the Trawl EM program. So for catch estimation, this is the information that the in-season managers will use to manage the pollock fishery, right? Most of the data is captured through e-landings. It's the delivered catch. As I mentioned before, very low amount of sorting, very low bycatch, right? Most of that catch gets delivered. So most of the information that we use for management comes from e-landings. However, under the current program, we need, a vessel was out to sea, right? He may have sorted, we don't know. So our observers on those vessels are there to estimate at sea discard and also to collect the biological samples that are necessary for stock assessment. And years ago, we used to collect our salmon from those at sea samples, but we learned that the precision wasn't quite right. So we shifted to the creating a regulation that requires all salmon to be retained by the vessel, and then those salmon are what we call census. That means every salmon should be counted as the vessel is being offloaded, and so we have an exact count to the number of salmon that were harvested on a pollock trip, right? Under the Trawl EM system, we're using the same information. We're using the landing reports or the e-landings to record both the delivered catch and any at-sea discard. Now, I mentioned that we were focused on a maximized retention fishery. We'll talk about a little bit more here later, but there's some at-sea discards that will likely still occur. And so we use the information recorded in the logbook by the vessel operator is then entered into e-landings to capture if those events occur. Observers census both the salmon and the halibut now at the processing plant, so we have a precise estimate of both all the salmon and the halibut harvested in the pollock fishery. And then any other PSC prohibited species, that's like your crab and herring and stuff, are also sorted and enumerated during the offload. And I've already mentioned at-sea discards are reported via the logbook and then entered into e-landings. And I should note here that observers are sampling 100% of all landings in the Bering Sea, but due to the nature of the fishery, only 30% in the Gulf of Alaska. And so what's the main difference between the two fisheries? Well, AFA, American Fisheries Act, Bering Sea pollock fishery is 100% monitored. It is a catch share fishery. It gives the flexibility for the processing plant and the vessel crew and processor workers and everybody to work together to do efficient. Where in the Gulf, it's still a race for fish. So we needed to take into account that and just moving, the amount of fish coming in at, it was hard for us to get to 100%. I want to focus a little bit on PSE estimation. I already covered some of this, right? But the main thing is the EM system now allows for verification that all salmon were retained. Under this EFP, all PSC is counted during offload and reported by the observer. Any salmon and halibut required to be retained are now accessible for donation to the Prohibited Species Donation Program. So instead of waste at sea, they can at least go to perhaps those in need. And then other PSC species are sorted and enumerated, as I mentioned, and the shoreside observers can verify that these PSC species are reported. They are they are rare circumstances. Honestly, not a lot of crab, not a lot of halibut. Sometimes they can get into a little bit of herring, but generally speaking, that's more of a rare occurrence too. And then finally, we talk about the biological data collection needs for stock assessment. So under current regulations, right, the observer is on the vessel, on the back of the vessel, collecting that information. They take a species composition sample, they collect their pollock otoliths, the pollock lengths, and any other biological data that's requested by AFSC to support stock assessments. Underneath this program, we've shifted that to the observer at the plant. Since we can verify that the catch is unsorted, the observers can collect their samples during offload and perhaps have a more stable place, an easier place to work to collect those pollock otoliths, lengths, and other biological data as necessary. So I'm going to shift a little bit to talk about the goals of Trawl EM, and these were the goals that were established under the EFP. And so the first goal is to demonstrate maximized retention can be achieved by pelagic trawl catcher vessels. I could read through all these, but I got a separate slide for each, so I'm just going to skip forward. So as I mentioned, goal 1 is maximize retention. The Trawl EM EFP is focused on assessing that compliance monitoring EM system to verify that all catch is being retained per regulation, and if any at-sea discard occurs, attempt to identify it to species if possible and estimate the amount. So early on in the process, we identified that there's certain regulations that are currently in place that require discarding at sea. And the three primary examples of that are maximum retainable amounts. These are when species are closed to directed fishing, vessels are limited to a certain percentage that they can retain of those species, right? It's to promote more use of fish and reduce waste, but also puts a cap on to prevent people from continuing to harvest more of a species that could affect management. Another example is the pollock trip limits. Pollock trip limits only exist in the Gulf of Alaska. They do not exist in the Bering Sea. It's a way it was put into place for stellar sea lion conservation concerns, but also as perhaps a tool for to limit the amount of catch to assist in the in-season management of the fishery. And finally, the regulations also require the discard of all halibut, crab, herring. As I mentioned, salmon used to be in that list, but they are now required to be retained for several years now. So we identified that we needed an EFP, exempted fishing permit, to allow these vessels to be exempt from those certain regulations that require discard in order to promote, testing this maximized retention and allow for the data collection of unsorted catch data shoreside. So we had there it was a concern of both the fishing vessels and the agency that we wanted to try to maintain the spirit of the current regulations and reduce changes in vessel behavior. So the EFP imposes performance metrics, which I think it's easier to give an example. So there's the 300,000 pound pollock trip limit, right? If we're in a maximized fishery and a vessel sets a net and thinks, ends up with more catch than he wants, we didn't want him discarding that at shore. We wanted to allow him to bring that catch to shore, but we wanted to remove some of the financial incentives that might make it so every delivery was over 300,000 pounds, right? So the performance standard takes the value that's in excess of whatever limit is being assessed, and it's donated. I don't want to go into too much details here, but there was a lot of thought put into how to try to maintain the spirit of the regulations in a flexible thing and still gain maximized retention. And it seems to have worked pretty well so far. So the maximized retention rules. Almost all catch retained for delivery. Why almost all and not all catch? Well, in reality, most trips have no discard events. And if they do, they're small discard events. And they're reported as required. So we can take that into account in our management. Some discard events are unavoidable, like a tear in the net or a blown out panel, and EM captures these discard events that may not have been available to observers prior, right? That camera is always on. The EM review, we review everything. So we started identifying when those happen. The vessel operator usually knows, usually records it in the logbook. So we were capturing that data, but we didn't, prior to the EM system, we would not use those discard estimates from the vessel operator. We relied solely on what the observers reported to calculate at-sea discard rates that were then applied to the fleet, right? So we have a little bit more precision in our estimation of any discards that occur.
Josh, I think we've lost your sound if you can hear me. Josh, if you can hear me, we've lost your sound.
Hello?
We've got you back now.
All right. Sorry about that. I don't know when I stopped. Do you know when I stopped?
I do not. I'm so sorry.
All right. I will just, I don't know what happened. Okay.
Okay, so we hear that you stopped where you were demonstrating where what the EM reviewers review.
Oh, way back when. Okay. Sorry. Like, I apologize. Was it at the end of the pictures?
No, it was maybe a minute ago. We're not too far off.
Okay. All right. Well, I'll just back up here and I'll just start with the goals again. Sorry about that.
No
Um,
problem.
so you know, so we'll start with the goals. Maximize retention was the goal. The EM system is designed to monitor compliance with the regulations, and it's not focused on catch estimation. We use the EM system to verify that catch is being retained for the regulation, and then if any at-sea discard occurs, identify the species if possible and estimate the amount. So we learned early in the process that there were certain regulations that require discarding at sea. The maximum retainable amounts, these are species close to directed fishing. There's a limit on how much you can retain. You have pollock trip limits, which are 300,000 pound trip limits. And then the PSE of halibut, crab, and herring are also required to be discarded. So we identified early that an EFP was needed to exempt vessels from regulations that require discard in order to promote meeting that maximized retention. Something that was learned through the development of this is that vessels were concerned that if we didn't have some of these limits in place, and the agency was concerned as well, that vessels may change their behavior to take advantage of those relaxations of the regulations. So performance metrics were implemented to maintain the spirit of the regulations and reduce changes in vessel behavior. An example is exceeding the pollock trip limit by a large amount can result in loss of revenue of the fish in excess of that limit. So if a vessel brought in 350,000 pounds, right, the value of the catch in excess of the 300,000 pound would be donated to the North Pacific Fishery Research Foundation to support future development. Maximize retention rules implemented. Almost all catch retained for delivery. And why almost all? Well, in reality, most trips have no discard events. Some discard events are unavoidable, like a tear in the net, or a blown out paddle. And what we learned is the EM systems capture these discard events that sometimes may not have been available to the observers due to safety. You know, as the vessel crew is bringing the net in, right, back by the doors at the stern of the vessel is not the safest place to be. So observers may not have seen that, but vessel operators would typically see it, and they would report that in their logbook. So now we're capturing these events through the EM system and using the information that the vessel operators are doing. Prior to the EM system or EM EFP, we would not use any of those discard information that the vessel operator would report in their logbook. We would rely solely on the observer observations to calculate the at-sea discard rate and apply it to the rest of the vessels. As we thought about this a little bit more, a few other exemptions started to come up. Large sharks, as you see in the picture, they're too big to store. They don't go in the hold. They're hard to deal with. Already observers kind of took that outside of their sample. So there was an opportunity to work with that. Jellyfish provides creates a product quality issue. And then finally, vessel stability and safety. You know, sometimes you have a failure of an equipment that's monitoring your net and how much is in it, and you bring up too much that your vessel can't handle, right? So we wanted to provide an opportunity for vessels to maintain that safe environment for their crew. So all discards reported in the logbook, and that's reported in e-landings. And I just want to put out or just take a moment to talk about sharks here for a second. So large sharks are not usually accessible to our researchers due to safety concerns or when they're operated. So are when they're encountered, right? So early on in the process, we realized that we might have an opportunity to gain some very important and needed science on the sharks there. So as you see, we have a large sleeper shark here, and working with Dr. Cindy Trabuzio at the Alaska Fisheries Science Center, she came up with some measures and measurements and other things for the vessel crew to do to assist in the collection of necessary data that we need to manage sharks, and it's worked out pretty well. It's just kind of a unique opportunity that just kind of showed itself through the development of the EM system here. Moving on to goal 2, which is talking about, can we sample the catch shoreside? Can we sample unsorted catch shoreside? Can the observers have access to that? And so this is something that we focused on a lot in our meetings as we meet every 2 weeks to discuss and work towards collaborative solutions. And so early in the EFP, we identified that maybe we weren't meeting the targets, and that's what this table shows before. I mentioned already that the Bering Sea is a rationalized fishery. It's a catch share fishery, and we were pretty much spot on our goals and the collection of the data that we needed, right? But in the Gulf of Alaska, we had a little bit of challenge, and most of those challenges were communication related. And what I like about this is at the start, we only had 5%. We were only getting to 5%, and our goal was 30%. We were far away from our goals. The team sat together, we hashed it out, we had more meetings, we talked about options, we engaged processing plant personnel, and they really worked hard. Now, seasons in the Gulf are relatively short, so we didn't have a lot of opportunity in the A season 2020, but we still moved the needle in the right direction. Then in the B season, look, we met our targets. And I apologize for the red on the 32% there for species company. That should be green. And then we just started to receive data for the A season of 2021. We're a little bit below targets, but we also had some communication issues that we're still working on. So we're still ironing out the kinks. And that's what the power of the EFP and the EM development is it allows us that opportunity to work out the kinks and figure out what works for all parties. Goal 3, which is focused on the Trawl EM video review. Can we review this? The answer, I think, is yes. EM review includes all hauls. The EM review logs all problems with the video review, and that can include anything that's mechanical, any video gaps, any failure to report an allowable discard. An example of this might be vessel personnel grabbing a rockfish for dinner, right? That needs to be reported in the logbook. If the EM reviewer saw that, and they might mark that in the drive report. Record any discard of fish, both in the vessel control or not, and then any failure to retain all catch, you know, can result in further education and outreach. All identified problems are sent to NIMS staff, the EM service provider, and vessel owner. That allows the EM service provider and the vessel owner to address any problems with like mechanical or maybe there's certain behaviors on the vessel that need to be changed, like cleaning the camera lens or something like that. And usually these issues are resolved. NIMS staff will follow up as needed, and all issues are documented and tracked. And so we can track trends and increases in identified problems and work on more focused education and outreach to bring everybody in compliance, or identify that maybe we need to think a little bit more about a certain measure. So the EM review will record all that information about the thing, and then record some other information. As I mentioned, they'll try to estimate any weights of discards. That allows us to compare what the vessel operator's estimate was with the at sea, or with what the EM reviewer estimates. One thing we noticed in 2020 data is that the vessel operators tend to it goes both ways, but there tends to be a tendency to overestimate the amount of at-sea discard estimates compared to what the EM reviewers. So we're on the conservative side, which is a good place to be, right? And finally, there's a feedback loop to the vessel operator and other people, and that's what we call a drive report. And I know this is going to be really hard to read, but this is just an example of the drive report that'll come. And it splits out with different categories, and it identifies what was seen, and also, ways to address the issue, right? So take, for instance, in the middle there, logbook submitted complete, and the EM reviewer may have marked that rockfish kept for personal use not recorded in the logbook. Please record all in the logbook. And we found that it's really good that the vessel operators read these drive reports, and they follow the instructions. And we usually don't have repeats on issues that are identified. Finally, goals 4 and 5. Goal 4 is to demonstrate the EM cost effectiveness compared to at-sea observers. Unfortunately, data is not available at this time. The pandemic presents an interesting conundrum on how to tease out what are costs related to the pandemic and what are costs related to the EM system in a non-pandemic. So we have a little bit of work to do on that. And then finally, goal 5 was, can it improve salmon bycatch accounting for catcher vessels through the use of an EM camera system? And the answer is yes, right? We can now verify that all salmon are being retained to be there, right? Not just when the observer's on deck or watching, right? But the camera's on all the time. We also were really clear on what the regulations were, and we did a strong outreach to the vessels participating and basically put them on notice that any discard of any salmon will be immediately reported to NOAA Office of Law Enforcement for follow-up, right? Haven't seen much salmon discards, very few instances. I don't know the exact count. I want to say less than 3, but each one of those were remedied through additional outreach and education of the vessel crew. It usually was related to a new crew member that was unaware of the requirements under the EFP, regardless that it's also a requirement under regulation. But we got them in line. So, and also we have a project underway to explore the use of artificial intelligence to assist in the sorting of salmon. That may provide some additional opportunity for the observers to collect more, but that's way early in the phase. Finally, one interesting aspect of this system is the Western Gulf. The Western Gulf pollock fishery is much different than the Central Gulf and the Bering Sea. The vessels tend to be less than 60 feet, and due to the size of the vessels and where the pollock fishing actually occurs, the fleet out there uses tender vessels to support fishing and delivery of catch. So Trawl EM was developed by Saltwater to put on tender vessels to monitor the transfer of fish from the catcher vessel to the tender vessel and ensure that that catch is not sorted. So we can maintain that chain of custody, so to say, right? That this is unsorted catch all the way to the access of the observer. And here's just a diagram of a typical tender vessel. I'm going to end the presentation to talk about where we're at and where we're going to go. So we're continuing to meet every 2 weeks and discuss issues as they come up and work towards collaborative solutions. In May, the Trawl EM committee will meet to review reports on the data collected in 2020 and early 2021. The discussion will likely include a recommendation to the North Pacific Fishery Management Council to begin analysis for the implementation of Trawl EM in regulation. That would be presented at the North Pacific Fishery Management Council meeting in June. And they would, if the council chooses to pursue this into regulation, the timeline below, it's an estimate, but analysis through 2021, review in December and February by the council, regulation writing next year, and implementation in 2023 is the target. And with that, I'll end for questions, and I apologize for all the technical issues.
Well, Josh, you did perfect on timing. We've still got a little bit of time for questions, and so we'll ask any of our attendees now then to go ahead and send those questions into the chat or the Q&A area. We do have a little bit of a lag time, so Josh and I will wait here patiently while we wait for your questions to come in. And again, this technology is not overly easy to use, if you have not noticed over the last 2 days of presentations. And so really a big thanks to all of our presenters for learning this new platform. Really quickly, it is just not as easy as it looks. And so we have had a question come in from John Warenchuk. Great presentation, Josh. Is the EM required to be on all the time, including if vessels switch targets? i.e. start trawling for cod?
So this EM system is only applicable to pelagic pollock fishing. So a vessel has to be using pelagic trawl gear and targeting directed fishing for pollock. Um, uh, Maybe in the future we would look at expanding into other fisheries, but that is currently restricted. So the EM system has to be on all the time when the vessel is fishing pollock. The trips have to be distinct. You're on a pollock trip or you're on a mixed trip. You can't be in both. And so the EM system can only be on when you're on a pollock only trip. We're a little early in the phase to start exploring EM on like into peacod or arrowtooth flounder fishing. That's not the goal of this.
Thanks for the clarification. Another question from Mike Orcutt. What barriers, if any, do you see as the biggest barriers to implementation?
Well, we need to look towards we need to look hard at the data, right? We need to make sure that it's we're collecting all the data that we need for management and stock assessment, right? So we'll be engaging in that process through the analysis. At this point, I don't see any large barriers. We've worked through a lot of those barriers through these meetings, but I keep an open mind. We want to make sure that the system enables us to collect the data that we need to manage the fishery. But at this point, I don't see any large roadblocks. Funding is always a concern. We kind of have a plan for that, but we'll see what the future holds.
Thanks so much for that. I don't have any additional questions right now, but again, we do have that lag time a little bit. So Josh, if they do have questions that maybe didn't get answered in this forum or they're watching a recording of this, what's the best way for them to reach out to you to get those answers?
Sure. You feel free to reach out to me at my NOAA email address. It's josh.keaton@noaa.gov. So that is the best way to get in touch with me. Also, I would encourage you to contact like the principal investigators. That's Ruth or Julie. They may be able to answer your questions, but I'm willing to take any questions that you may have and try to answer them.
Outstanding. So much good information there. So with that, I think that's going to close out our session here today. So Josh, thanks so much for joining us and discussing your important and innovative work. So we'll be back for our next forum with Sea Grant right after lunch at 1 o'clock. And speaking of lunch, don't forget that Million Recipes is serving up fish tacos again today in the food truck outside the brewery. Josh, I know you're in Juneau, so sorry you can't be there for that, but maybe you can make some fish tacos at home. And while you guys enjoy your lunch today, be sure to visit the Expo tab and meet face-to-face with all of our exhibitor representatives. Thanks so much, everyone.